Okay, I think we'll make a start and people can catch up with us. So welcome everybody. Thank you for coming to today's seminar. My name's Caroline Martin and I work for WARM, Low Energy Building Practice, and I'm chairing today. WARM, we're a group of Passive House certifiers and designers and consultants and trainers and all sorts. We're one of the first Passive House certifiers in the country, and we've been involved in Passive House right from the start. And we are actually certifying the project that we're going to hear about today. So this webinar is the second of 6 webinars focusing on Passive House in schools. So, and this is continuing from the success and popularity of the Passive House Trust Educational Buildings campaign. So we had phase 1, which was all sorts of different education buildings, and we had 2-hour webinars on each one. And then this phase that we're in now, we're doing specific webinars for on schools, and this is the second one in that series, and today we're focusing on retrofit. Before I go any further and introduce you to our speakers today, I'll just do a bit of quick housekeeping. So you should, somewhere on your screen, hopefully at the bottom in your control panel, you'll have Q&A and chat windows. So any questions that you have during the presentation, put them in the Q&A bit, and any chat amongst yourselves, introducing yourselves, questions about what's going on, I guess, go in chat. So chat in the chat and Q&A in the Q&A, I guess. So you can post a question at any point during the event, but we'll have specific points in the webinar where we'll actually answer some of those questions live for you. And we'll also try and answer some as we go along as well. We'll see how we get on. So in a moment, we're going to ask you a question using the poll feature to make sure you're all wide awake and paying attention. So you should see that pop up on your screens any minute. Just to let you know as well, this webinar is being recorded and it will be mailed to all the attendees after the event. So hopefully you've all got a poll question that's popped up. And also thank you to our sponsors, which is Robertson, Hub East Central and Archetype. So there's some results here from your poll. Or at least everyone has heard of Passive House, that's good. So today we're talking about retrofit. So for those who know or not, the Passive House standard for retrofit is called ENERFIT. So you'll be hearing that quite a bit today. So let's move on here. So as I said, this is the second in 6, I think, webinars, and then we've got a client procurement workshop at the end there. So that we're doing retrofit today. Next week it's going to be new build schools. The next one after that is budget. Then we've got appointing managers and contractors, early stage design sessions, and then the workshop at the end. So moving swiftly on, we've got the project that we're looking at today. I'll let Sarah introduce it actually, but we've got Sarah and Alex speaking today. So Sarah Lewis is an Associate Director at Hampson Barron Smith Architects based in Edinburgh. She's a Passive House consultant and all-round Passive House superstar. And basically, so since joining Hampson Barron Smith in 2014, Sarah's been project architect and Passive House consultant on many innovative and multi-award winning projects, delivering and working on some of the UK's largest Passive House developments. So huge experience there. She also wrote the book. In 2017, she published the 2nd edition of her best-selling rebirth called PHPP Illustrated, which is basically tells you how to use the modelling software, and it's the only book really out there that tells you how to do it. So, so that's a lot of knowledge in there. And 2020 for Sarah was the year of retrofit, the year of ENERFITs. So Sarah completed an ENERFIT of her own home, And also she was involved in leading the team on the project we're going to hear about today, which is St Sophia's Primary School for East Ayrshire Council. So we're also then going to hear from Alex Brown, who's the client. He's the project manager. He's the project manager on this particular project, working for East Ayrshire Council, and he's been there for 19 years now. And he's also a qualified architect and a passive house designer. So there's lots of knowledge and experience in here. And we've also got in the background Alistair Kidd and Magnus Dowie, who are also project managers and they'll be joining us at the end, hopefully, for panel discussion, and we'll also field any questions as we go along that they can answer. So without further ado, I'm going to pass over to Sarah, who will introduce the project and how today's going to pan out.
Hello. Hopefully my screen sharing is working and you can all see the presentation now. So as Caroline said, I'm Sarah Lewis, Associate Director and Passive House Consultant at Hampson Barnes Smith. So firstly, thank you so much for joining us this afternoon. We are all extremely excited to be working with East Ayrshire Council and the whole team at St Sophia's School on this landmark development. It's a deep energy renovation of this primary school, and it's going to be constructed to set new benchmarks for sustainable development. So we're not only meeting the requirements of the Passive House ENEFIT certification, but we're also going to be creating a healthy new learning environment for all the pupils at the school. So it really is an innovative modern development with environmental excellence at its core. So we've split the presentation into 4 sections today, and we've broken these up with a bit of Q&A, as we just want to try to keep everyone engaged, and we really appreciate that an hour is a long time to be sitting just listening. So please don't be off checking your emails or doing other work. If you can try to stay with us, and we'll do these Q&A sessions as we go. So we're trying to not speak at you for more than 10 minutes, which reminds me I should put on my timer so I don't go over. There we go. So I'll start off the session today just to give a brief overview of Passive House and ENEFIT. It's great to see that so many of the participants today have heard about the Passive House standard, maybe not so much with the ENEFIT standard as it's newer in the UK. So I'll go through that with everybody. And I'm going to look at how that sits within the current existing Scottish school standards that we've got. And again, we'll have a Q&A directly after that. Then I'll hand over to Alex from East Ayrshire Council to discuss their decision to aim for the ENEFIT standard at St Sophia's, and he's going to cover some of the project's kind of key objectives and talk through some of their procurement decisions. And in the final section then I'll cover our kind of approaches to ENEFIT at St Sophia's, and I'll end with a little bit of information on the embodied carbon investigations of the current designs and the decisions that we've made to date. And that end section might be slightly longer, maybe closer to 15 minutes, but that should still give us a good 15-20 minutes at the end for questions. Although I appreciate we started a couple minutes late, so we'll try to speed things up as we go. So the Passive House ENEFIT standard, just to briefly explain the term, is an internationally recognized leading low energy build standard for renovation projects, and it's been successfully implemented all over the world now. It's a voluntary standard and it reduces the building's ecological footprint. It results in these ultra low energy, healthy, comfortable buildings that require very little energy for space heating or cooling. And these were the attributes that really made us want to adopt the ENEFIT standard at St Sophia's. And it really focuses on that reduced energy demand by design for this project, rather than looking at offsetting the energy with technology. So the school will be designed with this fabric first approach and achieve a thermal bridge as far as possible in an existing building, and draft-free build envelope, which is going to be exceeding building regulation requirements many times over, even for a new build. And at the same time, we'll hopefully show through the presentation today that we will really be maximizing health and comfort. So the Passive House standard and its ENEFIT version is really at its heart a rigorous comfort standard that ensures a building is free from drafts, free from cold spots, free from excessive overheating, and provided with this constant supply of fresh, clean, filtered air throughout the day. So it's very healthy, and it does all of this while using a minimal amount of energy. So just to be clear, the ENEFIT version of the standard uses the exact same key principles as the full standard. So you've got the continuous thermal envelope, the solar gain, which you need to maximize in winter, control in the summer. It needs to be thermal bridge free as far as possible. It needs to be draft free, so airtight. And then you've got that ventilation through the mechanical ventilation system. And most importantly, it has to be modeled using the software PHPP, the Passive House Planning Package. And that's really critical to eliminating the performance gap. So it's very much a worldwide standard. It's being implemented all over the globe. As you can see, Scotland and the whole of the UK, in fact, falls within the temperate zone, which is marked in dark blue. There are two methods to calculate the Passive House NFIT standards, and you can certify using either of those methods. We don't have time to go into it in detail today, but I'm really happy to answer any questions that any of the participants have during the Q&A session. So Synthesify is going to be certified using the heat demand method, which requires the heating demand to be reduced to no more than 25 kilowatt hours per meter squared per annum. And to put that in context, because that figure might not mean much to some people, the building's currently using over 200 kilowatt hours per meter squared per annum. We're looking at about an 88% reduction in the space heat demand. So Synthesify will be upgraded to the full NFIT standard through this kind of single construction project that we're planning, during which time the pupils will be using another school building. However, in 2016, the Passive House Institute actually introduced this other sort of step-by-step method, which I just think it's worth discussing just really briefly so that everybody is aware of it after the presentation today. So this method allows the upgrades to be carried out incrementally over years or sometimes even decades. The critical thing is that an NFIT retrofit plan is created, and that plans out the full retrofit so that each measure, when it is carried out, is done so in a way that supports the next step. And each one is incrementally building towards a fully certifiable NFIT building. So each one is making a significant impact on the carbon emissions of the building. So the NFIT step-by-step method it's got lots of benefits especially if you can't do a whole building NFIT as a one stage project. You know, each element in a building already has its own lifespan and is going to be replaced at some point, and that will form part of the capital expenditure program that a council or a school authority has to spend on their schools. So if you replace the component at the end of its life cycle that's already planned in financial planning, and you're just doing it to a slightly higher level to meet the NFIT standards. So it's the most affordable option in terms of Passive House NFIT upgrades, and it makes sure that the initial investment is taken advantage to its fullest. It's easier to finance because it's spread out over lots of steps, and you avoid any missed opportunities or locking in poor performance by planning the whole thing out at the beginning using the PHPP. And it's really important to remember that you are affecting change to a building every time you do energy improvement works, and that might be the moisture balance or the airflow in the building or even the surface temperatures. So your design team need to be well versed in that to make sure that everything that's done to the building is to the benefit. This slide hopefully speaks for itself. So I'm hoping that everyone can identify the home in this 1960s terrace. The image really highlights for me, the comfort improvements which the NFIT standard brings to building users. If you just think about how uncomfortable it is to be in a cold, drafty building and how that's been eliminated. And that brings us on nicely to the most important result in my eyes for an NFIT upgrade, and that is the health and well-being aspect. NFIT, like the full Passive House standard, requires filtered, fresh, preheated air to be provided into all of the teaching spaces in a school. And I don't have time to go into this graph in detail, but I'll just quickly point out the key takeaways. So the green dotted horizontal line is the recommended upper limit for CO2 parts per million, which really sets the healthy air quality target for schools as 1,500 parts per million. So you shouldn't go above that. And as you can see, the green block, which is the Passive House school, is the only building monitored here which successfully stays below this line. The building regulations, which is in pink, and the building regulation compliance school, which is in blue, both fall significantly over that line, peaking at 4,000 and 5,000 parts per million respectively. So this is a really interesting graphic, and it's looking at the impact those CO2 levels have on our decision making. And I'm sure that the Passive House Trust are making these slides available to you after the presentation, so you can take a bit more time over it. But to keep to time, I'll just talk quickly over it for now. So the colored dots represent the average readings within the extent of the readings recorded. So it's showing very clearly that at 2,500 parts per million, which is the black dots, most types of decision making are below average and in many cases dysfunctional. So can these really be considered acceptable learning environments for our children? So I'll leave that as a question with you all today. Our ENIFIT approach is primarily targeting improving the comfort and energy performance of the existing school building. These graphics were produced from data in the LETI guides, which you may all be quite familiar with, because those are great guides. If you've not looked at them, please go away and look them up. You can download those for free. And this is data relating to new build schools. And effectively, the first big circle is your total carbon pie for a new school building. And as you can see, the major contributor is the yellow, and that is representing operational carbon, so the energy used by the school in operation. And as you can see, in a standard building, that is the major contributor. However, when you have a very low energy building like a passive house or an ENIFIT, suddenly the building's not using very much energy. But then the other parts of the carbon pie become more important. So while we're not focusing on embodied carbon through this project, it is a significant contributor to the whole life cycle of the building. And we are very conscious of it in all of our projects. And it's obviously a very good reason why we should retrofit rather than rebuild when we can. So I thought it might be interesting for the participants today just to see how the ENIFIT standard sits within the current Scottish Schools programme. So the Learning Estates Investment Programme sets a target for funding at 67 kilowatt hours per metre square per annum, and that's total energy use in the school, not just space heating, which was the 25 target I mentioned earlier. So this is total energy. The passive house set and its equivalent ENIFIT set a slightly different metric for how they set the limit, but you can easily take out the data for this, the equivalent data out of the PHPP file. So the St Sophia's final energy demand sits at 67 kilowatt hours per metre square per annum if we're looking at a direct comparison with the Scottish Schools target. So we can see that sits underneath the target for new build schools, and that is also the target that they're going to be setting for their deep energy retrofit program as well. So this is very important. So the funding program is linked to performance, with the funding being paid after, I think it's 3 years of post-completion, and it's paid in line with performance in use data. So if there's no performance gap, great, you get full funding. However, it reduces thereafter for every extra kilowatt hour the building uses, up to a point where you can lose all of the funding. So this is where the passive house standard really comes into its own, and I'm sure Alex will talk more about that when he explains why East Ayrshire Council have set that as the build standard. Now I've got one more slide, and I see I'm at exactly 10 minutes, so I need to do this one quick. But this project is also going to be part of it's a Pathfinder project for the Net Zero Public Sector Building Standard. Had to read that from the slide. I always get tongue-tied on that, but it's a great standard which has been produced in Scotland, and it's sort of a challenging, incredible route for a project to get to true net zero. And objective 3 of that talks about operational energy, and again the targets for the 67 kilowatts from the school funding is mentioned in that as a good target to set for schools. So again, using the ENIFIT or passive house is a way to achieve the net zero public sector building standard. Objective 3. So I've spoken for quite long enough, so let's stop and we'll do some Q&A for 5 minutes before I pass over to Alex.
Great, thanks, Sarah. Right, has anyone else got any more questions? If you have them, please stick them in. Yeah, there we go. People are digesting what you've said now. We've got one straight away though here from Pete. He says, is the embodied carbon in the ENIFIT / passive house that you just showed higher or lower than the building regs one, given it's more insulated, triple glazing, etc.? Do you know?
That's a very good question. I don't know. That was the research from LETI, so that data is definitely in the documents because they've been very good about explaining exactly where all the numbers come from. I would say that obviously there's more embodied energy the more material you use. So in terms of insulation products, if you're using 100 mil or 150, there's more embodied energy required, obviously, for the 150. But there's more of a difference in embodied energy depending on what type of insulation you specify. So those kind of decisions are more important in terms of embodied energy than the depth of the insulation. So for example, if you're specifying a wood fiber, or you're specifying like a phenolic insulation, a petroleum-based insulation, it makes a much bigger impact than just changing the thickness of the insulation. So it will have an impact, but it's not a key consideration. I wouldn't say it's not so significant.
We've got a second question from another Peter, different one. How much overlap between Passive House / Enefit and the WELL standard is there? Given Passive House addresses some wellbeing issues, is WELL superfluous on a project, or is it still useful?
I think it's still useful. I think that the Passive House standard very much, although by default it creates very healthy buildings, but all these other standards can be layered on top of the Passive House standard. So, you know, for example, the Passive House standard at the moment doesn't have a specific section that looks at embodied carbon, although there's plugins you can get. But, you know, laying on top of Passive House a target for embodied carbon is good. Laying on top of Passive House extra metrics for health and well-being is good. You know, the Passive House standard doesn't say you need to use low VOC materials, for example, but that's something that we would want to do in our schools. The fact that you've got the mechanical ventilation is great because you're constantly getting the fresh air, but if you can also use healthy low VOC materials, that's great. So yes, I would say the more things you can incorporate into a project, the better.
Brilliant, thank you. Shall we crack on then? And I don't think there's no more questions popped up. Oh, one last one. Haha. A cheeky question. How much did you spend converting your house to Passive House standard?
Well, I do, yeah, I have some information. I do have some information on the domestic sector. I'll see if I can, I'll pull it up and we'll do it at the end, because I've got a list of kind of typical costs for like a one-off house, a tenement building, a flat. So I can kind of give you where we are in the industry, and I'll tell you how much we spent on ours as well. So we'll do it at the end.
Perfect. Okay, I'll hold that one to the end then. Okay, let's move on then. Are you carrying on, or are you passing over?
Passing over to Alex. So I'll pass over to
perfect.
Alex Brown from East Ayrshire Council now.
Okay.
Hi everyone, my name's Alec. I'm the project manager for St Sophia's project. I'll go through just very briefly, as much as possible, a sort of potted history of how we got to where we are, and lead up with some of the questions. But forgive me, I've got a sort of written script here that I'll read from, just to allow me to get through all the salient points and not miss anything else. So let me first of all give you a brief background on the project. We carried out a condition report on the building in 2019, followed by an appraisal. It was then decided by our cabinet that a refurbishment for the building should be undertaken. Originally, the intention was to complete a typical refurbishment, as we would do previously on any school that we were carrying this out on, and basically just to extend the life of the building by 20 years. However, during the very early stages of the project, the development team believed it was a missed opportunity, and that we could also, or should also, consider our obligations under the terms of the Climate Change Act and future commitments in reduction of greenhouse gases to net zero by 2045. So in order to achieve this, we need to find new ways to design and construct our buildings, whether they be retrofit or brand new. Following detailed research, we came to the conclusion that the building should be retrofitted to an Enefit standard, critically within the available budget allocation. Sarah has also already given you an introduction to Enefit as such, so I won't elaborate on that any, but we did see an opportunity for future learning for our staff. Having put them through Passive House training already, they are now taking a lead role in certain aspects of the project. But it was clear that there was a need for assistance for our team, as it would be the first project that we're doing, and we needed some expert help. That facilitated the appointment of Hampson Barnes Smith in May 2020 to take a lead role on behalf of East Ayrshire Council, or lead design role, I should say, on behalf of East Ayrshire Council, as they have a proven track record in delivering similar Enefit projects. for those interested in this, the appointment was made through the ESPO framework. The Enerfit refurbishment of St Sophia School is not only an exciting opportunity for East Ayrshire Council, it is also a way for the council's in-house team to test new building techniques, which we will hopefully replicate and use in future projects. But as this is also the UK's first ever Enerfit refurbishment of an existing primary school, the project provides a unique opportunity for shared learning across, importantly, the public sector in Scotland. The project team have therefore been working in partnership with colleagues from Scottish Futures Trust since mid-2020 to make the best use of early learning opportunities. This partnership approach with East Ayrshire Council's willingness to share the learning has led to extra funding for the project as part of the LEAP funding, the Learning Estates Investment Programme, and that came through in December 2020. As Sarah's already mentioned, the LEAP funding, it's quite an innovative way of the government funding councils. This was subsequently followed by a small grant in January 2021 from Zero Waste Scotland, who are also very keen on maximising any learning for the project. New slide, please, Sarah. The Scottish Government creating places policy statement emphasises the importance of design-led procurement, that by achieving a high quality of design, which we can then deliver significant benefits to the end user. Following discussions with various stakeholders, the following key philosophies have been adopted for this project. So quality, not only does the design need to be of a high standard, but the appointed contractor must also deliver to a robust and durable construction if we are able to meet the Enerfit requirements. The flexibility, the design must build in flexibility to ensure the opportunity to share the facilities within the school and maximise the use throughout the school, and externally, importantly. Adaptability, the design must adapt to the requirements of the changing learning environment and provide options to expand in the future. Internal spaces, the internal spaces must make the most of the natural daylight and promote health and well-being. All of these items form part of the brief that was given to as part of the appointment for Hampson Barnes Smith. External environment, the landscape design must ensure a connection with the natural environment and maximise the use of external learning spaces. Security, the design takes account of the safety of occupants and functional relationships between different parts of the building and its location. Next slide, please, Sarah. So St Sophia's is a small 1950s building located in the middle of Galston, which is a small town in East Ayrshire. It serves a denominational catchment of the Irvine Valley, and the existing building was rated as being a C condition as per the recent school estates management plan, and has a current roll of 95 pupils. And again, please, Sarah. The existing building, or the proposed new building that you're seeing on the screen now, is made up of a number of single-story the existing building is made up of a number of single and two-story elements and incorporates 3 level changes. These are obviously detrimental to accessibility and usability of the internal spaces. The building itself sits within a site of 1.8 acres, and access to the school currently down a steep access road, and existing classrooms also have limited access to external spaces. So what do we expect to deliver from this project? Delivering to the Enerfit standard creates a deep retrofit result. In a new school, delivering to the Enerfit standard creates a deep retrofit resulting in a new school, albeit working within the existing footprint of the structure of the existing school. This major refurbishment was only improve energy performance, will not only improve energy performance of the building, but will increase the accessibility throughout the school and its grounds, making the available spaces more flexible and accessible to all, and improve direct access directly from the teaching spaces. Last part here is more to do with the procurement, and forgive me, those of you who are within education, why did we choose Enerfit? As I alluded to previously, we interrogated our own information from previous projects, as well as research online that led to us, to giving us the realization in our minds that Passive House and Enerfit was the only method which has been tested over a period of years and consistently provided a result building performance that was predicted at the design stage. This, of course, will require attention to detail and performance we, as a council, have not yet tried to achieve. The question of why to gain or whether to gain certification, this was posed as a very early option once we had decided to go with Enerfit. And the basic answer to this is formed in 3 separate areas. The first being extra quality insurance or assurance. This comes from an independent source, so the certifier is independently appointed by the client directly, with no other influential criteria other than those set by Passive House. So his or her criteria is only set by Passive House. There is no monetary terms involved in that. That's for the design team to take care of. The performance requirement set out by Passive House certification are demanding and a level of construction in many cases well beyond the current building standards, like achieving the air tightness of 1. Our current building standards in Scotland only ask you to achieve 10. So the air tightness levels here will be 10 times better than what is required for the building standards. Construction assurance. The contractor is also to buy into the process, as they are responsible for achieving the certification. And as I noted earlier, the air change rate is not tested at the end of the project as we would normally previously have done, but this is tested 3 times, before or pre first fix, post first fix, and then a final test. Each one of these tests had to be achieved before the contractor can then progress with the building. This is quite crucial, considering that more often than not, these pressure tests are taken at the end of the building when it's very difficult to actually achieve any corrective measures. The procurement route that we chose for this, again, a very important part, is a traditional procurement approach. This means that the client has or retains the design control. We did, however, adopt a 2-stage tendering process to benefit from early contractor involvement at the design stage. This was recommended by Passive House practitioners and seen as an approach which would assist in the buildability advice, particularly useful as we see Enerfit as a new approach to refurb. We also included at the early stages an open PQQ stage to invite tenderers for the first stage of the tendering process. The first stage tendering process was based on quality and price, pre-construction services costs, main contractor prelims, overheads and profit, with the second stage tender negotiated based on an open book market testing of work packages. For the contractor, for the main contract itself, the NEC4 contract suite was selected because it promotes partnership working and collaboration, very important when you regard Passive House. The contractor has been appointed at stage 1 on an NEC4 professional services short contract, and stage 2 will be an NEC4 engineering and construction contract, with the main option for lump sum fixed price contract at the end. That's the end of my presentation, and thank you very much for taking the time to listen.
Having trouble with my camera there. Thank you, excellent. Really interesting. We've got one question. I don't know if anyone else has got any specific questions that they want to ask Alex, but we can also answer questions at the end with Alex's colleagues as well.
Yep.
So if you think of some later on, then put them on the Q&A. So we've got one question here. In broad brush terms, what is reasonable percentage increase to allow to the initial capital cost of an Enofit school refurbishment versus a normal refurbishment? And which are the building elements that are subject to cost differences?
Okay, so we knew this one was going to come up. I would rather leave the details of this to my colleague Alistair Kidd at the end, as he's the expert on this. But basically we have, as I said before, this was done under the existing allocated funding. So there was no increase in funding allowed for this project when we undertook to decide to do an Enofit project.
I think Alistair is typing an answer as we speak as well, so we'll see how we get with that. What the two-stage procurement that you mentioned, could you describe that a bit more?
Okay, again, probably best left to Alistair. I know a little about this. The NEC4 professional suite, it allows for collaborative working, and that's its big sell point. It's the first time we've used this process, but we're finding it very useful in the fact that the contractor is involved at the first stages. So when we're at the current stage, we're at stage 3, and the contractor has become involved and will be able to feed into the design, and in particularly importantly, the buildability of the design. A typical example of what can come from this, a previous project that we had, there was steelwork noted down on specific sizes for this project. And it wasn't until the contractor was involved laterally that they had said, if we had increased the size of the steelwork, it would have become a standard size and would have been half the price. So this is the sort of involvement that's worthwhile having a contractor involved at the early stages with.
Perfect. And there's an interesting question here from Hershus. What is the lifespan that you expect from the Enofitted building?
That's something that I've not been involved with before, so Sarah may be better if she can to answer that one.
One for you, Sarah.
Yeah, that's fine. I mean, I think initially the contract, the sort of requirement in the employer's requirements was a minimum of 25 years additional life to the building. But when we were looking at the kind of whole life carbon, we were setting more like a 60-year target. And in terms of the specification of materials, that's what we're looking at, which is more like your standard new build lifespan for a building. So, but obviously we still expect buildings to last longer than the contracted requirement for the 60 years. So again, we would hope that this gives the building a new life for the next, I don't know, 100 years or something, but it's certainly a very robust standard in terms of the fabric of the building. So it's protecting the fabric. That's one of the things which Enofit's very good at. So hopefully a nice long life.
Perfect. Well, thank you, Alex. And I believe that Sarah's going to finish off now, and then any more questions we'll take to the panel at the end.
Great. I'm conscious that we've only got Alex and Magnus, our clients, with us until 4 o'clock. So I'm wondering whether is it technically possible for me to like spin through to the end and pull up our kind of big Q&A section, and we almost slide it in now? Is Alistair or Magnus able to turn their, I'm not sure how that works technically, or whether it has to wait till the end.
To see
Nobody's doing anything.
We'll see if technical whizzes behind the scenes.
There we go. Look, there's Alistair.
There we go.
Oh, this is the presentation in fast. There we go. So we can do 50, we'll do 15 minutes. If there's more questions, we've got Alistair, and then I'll go back and we can talk through the Enofit approach with people who can stay on a little bit longer. It feels like, I just feel like everyone's here today to hear from the clients rather than
Perfect.
us. So let's do that.
So do you want to do the questions now? Then we could go back over some of those ones that were just asked with Alistair.
Yeah, that's fine. I'm happy to
Yep.
put the question across then. Hi everyone, welcome. So just to explain, I'll get into a wee bit of detail here. So the budget for this project is based on, I don't know how many of you will be aware of the Scottish Futures Trust. It's an organisation within Scotland who set base metrics for the learning estate for construction projects. So they have a cost per square metre metric for both new builds and refurbishment projects. Now it's currently at the same rate. Within that cost metric that they have set for us, they have built in a 12% additional allowance for the costs associated with Passive House and Enerfit. So the cost per square metre that we're currently working to, and this is an all-in cost per square metre for the St. Sophia's project, is based on base date. I'm just going to bring up, so I'm telling you the exact figures here. So it's £3,742 per square metre, and that is based on Q4 2017. So we're allowed to obviously inflate that figure based on whatever the predictions are through BCIS. So that gives us a working total for this, a working cost per square metre of this project of £3,891 per square metre. Now that's an all-in cost per square metre. So in terms of, probably just be more interested in the prime prelims, overheads and profit, so the actual construction cost per square metre. So as at stage 2, we were targeting a figure of around £3,294 per square metre. However, through the discussions that we've been having with the Scottish Futures Trust, whilst they set the same cost per square metre target for new build and refurbished, ideally they want to target a figure that is somewhere around about 10% below the new build rate. So whilst we're achieving at stage 2 a cost per square metre that is equivalent to the rate that our Scottish Futures Trust colleagues have set, we are currently targeting through stage 3 a figure of about 10% less. So about 10% less all the figures that I've just read out to you. Does that make sense?
Yeah, I think I would just add, Alistair, the question was how does it compare with a sort of traditional refurbishment? Well, I don't suppose there is a traditional refurbishment. You can do carpets and paintwork very cheaply, right up to a deep retrofit the way this is. I mean, this building will look and feel like a new building. It'll be zero sort of carbon ready, 60-year lifespan. So it's essentially a deep retrofit that's creating something like new. You know, it should have a new feel. It's not just a light refurb.
I mean, yeah, you have different ranges of refurbishment, but I going back to the original point that I raised, the Scottish Government have allowed for a 12% uplift. So from what you might assume to be a full refurbishment, and now a full refurbishment to an Enerfit standard, they're allowing around about 12% on the budget allocation that we get.
Yeah. We did some research on a project which was a community centre, which was the first building, non-domestic building to be retrofitted to the Passive House standard, and that was completed in 2010. And that project, that was when I was working at a company called Bear Architects, and they did some research post-completion just to see how much it would have cost to completely renovate the building, but just bring it up to building regulations compliance, so the current building regulation compliance at the time, and then how much extra it costs to get to the Enerfit standard on top of that, and that cost increase was 7%. But that was assuming a base standard full upgrade of the building, but just to building reg compliance. So that's the kind of, I mean, as I think Alistair, or as Magnus said, actually, it's very difficult to know what you're comparing when someone says to a standard retrofix, what is the standard retrofit, what's the baseline?
I will also say we've put the cost per square metre metric under quite a lot of challenge for this particular project, because not only are we looking to deliver to an Enerfit standard, we're also targeting elements of net zero carbon as well in terms of the new building standard in Scotland. So, you know, the budget is under quite a lot of pressure and quite a lot of strain. So, but so far through stage 2, as I say, we're in line with the metric that's set by us by SFT, and we're looking to try and deliver something around about 10% less than that once we get to stage 3 and beyond.
That's great. Thank you, everybody. Has anyone else got any questions that they want to put to the panel? If you have, then type away in the Q&A. See if anyone just can start with anything following all that information, all those numbers.
While people are thinking what will it cost, I'll give the little summary of where the kind of industry figures are for domestic retrofits. Since
yes, that would be perfect. Yes, going back to that first question we had.
This is the industry figures. So reaching out to other architectural practices who are doing Enerfit projects. This is the kind of data that we're getting on Enerfit projects. So one-off projects, optimistically, people are hoping at the moment that the tenders are going to be coming in around 45 to 55,000 for each unit. So that would be for a one-off house, but that's still assuming that it's applied at scale. Then blocks of tenements are coming in about 37,000 per unit. And again, that's got to be applied to the whole block, the whole tenement block. Multi-story flats are coming in at around sort of £20,000 a unit, but that would just be the energy improvement works. And often when we do like multi-story flat renovation projects, there's actually a lot of other upgrades that go on as well. So the projects are a lot more expensive than that, because we're quite often doing fire upgrades, new fire escapes, fire doors, improvements to like communal areas. And then the schools was the last on my list, but we've covered that one, so I won't do that. So that's the kind of range of prices that people are looking at the moment around. And there's a new question that's come in, which is,
yes,
is the plan to decant the school and pupils? Yes, that is the plan. East Ayrshire Council are very fortunate to have a building which they use to decant other schools into to allow them to do upgrades. So this school will be decanted for 1 calendar year effectively, from summer 2022 to summer 2023.
Great.
Cool. Well, if that's all the questions, shall I spin back? And,
yeah, I think so. Yeah, we'll do your last 10 minutes and then we're perfectly on time.
Excellent. Well, thank you very much,
you.
Alistair and Magnus. That was really great having you both on the call. I think everybody will have got a lot out of here.
Thank you. I'm just going to hang on, Sarah. I don't need to go till 4 o'clock, so I'll just hang on.
Okay.
And if anyone has any questions, just put them on the question chat and I'll try and answer them.
Perfect. Thank you, Alistair. Okay, so I'll spend the last kind of 10, it might go over a little. I think it usually takes about 15 minutes. And in fact, I'll turn my alarm on again. So this slide, we've got a pie chart here, and that's showing the existing energy split at St Sophia's. And as you can see, a whopping 79%, so almost 80% of the current operational energy in the school goes on space heating. And I was actually just in the school on Monday, and it's quite warm at the moment. All the radiators were on, and the school building was not hot, it was just comfortable. So it shows how much energy that building needs. And as you can see in the graph on the right, that's showing you that the Enerfit approach really makes the biggest reductions, because we're targeting the fabric of the building and we're reducing that space heating demand by 88%. And those calculations are done in the PHVP, which is very good in terms of a methodology for eliminating the performance gap and understanding how the building really will perform. So to do this, first, we're retaining the existing structure and external fabric as much as possible, which means that we're saving all of the embodied energy in the existing building. If the school was rebuilt, this would all obviously be wasted. So by retaining St Sophia's, we're able to reduce the embodied carbon by about 1/3, while at the same time carrying out such a deep energy renovation that, as Magnus said, the building's going to look, feel and perform much like a new school. So really it's the best of both worlds. So we completely wrap up that existing fabric then with insulation. It's a bit like giving the school a nice cozy jumper to wear, and it helps to keep in all that nice warm air when it's chilly outside. As part of our strategy to improve the performance of the shell of the school, we also looked at ways to improve the efficiency of the overall shape of the building. So that's where possible, we kind of rationalized the form with small infills or little areas of demolition and modest extensions. So it's kind of shaping the building to make it a more efficient shape. So these provided us with the scope to make significant improvements to the way the school functioned as well. So we used it as a design opportunity to create more flexible and better modern learning environments. And this is just looking at how we were iteratively looking at reducing the form factor of the building, so the ratio of the envelope to the usable floor area. And this slide shows, for example, on the roofs, I mean, for a single, effectively, it's a single story building. It's got a very small 2-story element, but there were 9 separate roof areas. So we've rationalized that down to 4, I think possibly 5 now, because there's a small area we need to keep. But that not only improves the efficiency of the shape of the building, but it also significantly simplifies our detailing and assists greatly with the aim to eliminate all of the thermal bridging, so the thermally weak points in the building. So the presentation today is obviously focused around energy and carbon performance of the school, but we have included a few slides here just to show the overall works. So a large part of the project has been to improve the overall layout of the school to better support the teaching that happens, and also to provide a fully accessible building for the children, because it's not currently fully accessible. So this plan shows the proposed ground floor plan, and the red lines indicate where we're either demolishing or rebuilding sections, and the blue hatched area is where we're providing a new 2-story element. So a large move was actually to take out this single story toilet block, which was on its own ground floor level. It was like a lower ground floor level, and combining that into a new 2-story element, which was a much more efficient use of the envelope of the building, and again, the detailing. So I'm not going to spend time now talking through the new layouts, but these slides are in here, so you'll be able to see them after the presentation, and I'd be delighted to bring them back up on screen if anyone wants to talk more about these. The key things to note are that the design reduces the number of level changes from 5 to 3, and it includes a new lift so that everything's accessible, and it prioritizes south-facing classrooms, which they were existing in those locations, but they're extended now to meet the recommended size for classrooms, because some of them were a bit small, and we've now got these breakout spaces, so it's creating a more flexible school environment. And the current kitchen, which was over here, which was very large, is being split up to provide a more suitable sized kitchen and an extra learning space. The first floor is almost an exact copy of the ground floor, and again retaining those south-facing classrooms. And again, that's the new stair core and lift to make it fully accessible. So then the next sort of part of the ENIFIT journey is to make sure the building is airtight. So to make sure that we keep all that warm air inside the school, and to make sure that it's much more comfortable than it is now, we have to give it this new kind of wind and airtight shell that removes all those uncomfortable drafts that currently whip around the building. And I've included this slide just to highlight the importance of establishing the approach to airtightness in an ENIFIT project right at the beginning, as early as possible, because that in effect will drive a lot of the decision making and detailing sort of development. The red line on this drawing is showing the line of airtightness for the school, and it's trying to make sure that you can draw it relatively easily all the way around the building without taking your pen off the paper. And you need to make sure that it's done in a logical way, and a way which is practical for a contractor to install on site. So a lot of work and a lot of the benefit of the pre-construction services agreement we have a contractor on board now, so we can have discussions about what would be the easiest way for them to install particular parts of that airtightness layer. And then to make sure that the school is also comfortable in summer, we designed solar shading to control the sun's energy entering the school. And then finally, to provide the very absolute best in terms of health and well-being, we put in this super energy efficient unit to bring fresh air into each teaching space, which is pre-warmed with heat saved from air extracted from secondary spaces such as corridors and kitchens. Now, I don't expect you to be able to read this graph, but I'll tell you what it's showing us. So the graph on the left of the screen is the energy balances at the moment. The graph on the right is the energy balances as they'll be after the renovation. The big takeaway here is really that we've got an 88% reduction in the in the losses through the fabric of the building. So this graph is really it just shows how great a tool the PHBP really is. So it's looking at where the energy savings are coming from. So this is looking at individually, you can look at the roof, the ventilation, the walls, the windows, and the floor, and you can see the percentage improvements. So our passive house software, the PHBP, really allowed us to target our interventions where they were going to provide the greatest value. And in this case, it was the roof where we also see the greatest savings. So these passive house proposals will be future-proofing the school for the demands of our changing climate. And through this project, East Ayrshire Council and the whole team at St Sophia's are demonstrating their drive for excellence and setting this kind of new high bar for the area and beyond, and opening the way for passive house Enofit to become very much a benchmark standard for school renovation across the country. So it is a very exciting project for everyone involved. Now, I've got a couple of minutes left, so I'll whiz through this section. I'm just going to talk about a little bit of this. So we were lucky to have an opportunity, which was funded through Zero Waste Scotland, to work with useful projects at the whole sort of the whole carbon kind of picture for the project. So we were looking at whole life embodied carbon, circular economy, and sustainable co-benefits. I'll just touch on the whole life embodied carbon assessment today. So the first piece of work that we had to do was actually to look and see how to set a benchmark for the project. So while there's LETI guides, GLA guides, RIBA guides, all these targets are for new builds. So we had to work out a benchmark effectively for retrofits. And we went through that process and we worked out a new benchmark and an aspirational benchmark for this project. And as you can see, the St Sophia's project sits right between the good practice and aspirational benefits that we've set for this renovation project. And I thought some of the audience today might be quite interested to see where the most carbon impactful work was expected to be. And this graph shows that by far the MEP equipment, then followed by the insulation and the floor finishes, but the MEP equipment is certainly the greatest contributor to carbon at the moment. And part of that is because part of this project is that we're completely off fossil fuels, so it's an all-electric building, and we're looking at using heat pumps, and the refrigerant in the heat pumps was the thing which was causing us the problem in the calculations. Even since we did this work, Mitsubishi, who are the currently specified heat pump provider, have come out with new refrigerants, so we already expect that we'll be able to reduce that quite significantly. So again, I probably don't have time to explain this slide, but I've included it just to show that the carbon payback in terms of the carbon needed for the refurbishment against the carbon saved through the energy improvement works, because it's a question that sometimes comes up, is currently 9 years. That's at stage 2. We're currently charging through stage 3, and all the time we're trying to look at ways that we might be able to reduce that further, so cut some years off that. And something which I think is just important to always keep in mind are the savings which are inherent to the project just by the fact we didn't demolish and rebuild. And these are shown in the dotted bars. So effectively, we're saving sort of half of the embodied carbon just by not knocking it down and starting again. So I'll just finish with some images of the current proposals, so you can see the look of the renovated school, the elevations on the top of the existing building, the elevations below are the proposal, and hopefully you can see how much rationalization there has been both to the building form and the window arrangements, which has been quite critical to getting the performance we need. And these are just a couple of 3D visuals of how the final building is expected to look. And then I'll just finish. Yep, this is the last slide. So our last slide is a timetable. So from our appointment in summer 2020, last year, through to the starting on site in summer 2022 and completion in summer 2023. It's quite a sort of drawn out program at the moment, and that was largely due to the decant timetable for the other schools that are using the decant school. So I appreciate that there's been a lot of talking. I've talked a lot at you. I hopefully haven't gone too quickly, but I was trying quite hard to keep to time because really this is about you guys asking questions. So I will hand back to Caroline and we can maybe start going through some of the questions which are up on the board. And
yeah,
I welcome anyone else
to stay on a bit longer. We have got time. Yeah, so yes, we've got a few questions here already for you. I'll start at the beginning. There's there's one back to budget again. I wasn't sure if this actually got mentioned or just didn't get picked up, but what was the actual budget for the Enefit at St Sophia's? I don't know if Alistair did mention that already.
Alistair's gone now. That question.
I know he has. I know.
No, he did. He gave the square meters budget, and I can tell you that the square meters school is around. Well, I've got the TFA, which is the Passive House one in my head, which is about 780 square meters. I think the gross internal area probably is more like, I don't know, maybe 820 or something. That's a yeah. We'd have to come back on that one. I don't
might
have
go and do the sums on that one. Do you know what the annual heating demand that the PHPP model is achieving?
Yeah, at the moment, as of yesterday or today, when I was fiddling around with the latest little bits, I think we're at either 22 or 23 kilowatt hours per meter squared per annum. So 25 is the cutoff. So we're under it, but we're not hugely under it. It's always a delicate balance of trying to make sure you've got a robust building, but not over designing it, so adding costs where it's not required. So we're at kind of 22, 23 at the moment.
And then we have another question that sort of follows on the heating theme. Did you do underfloor heating as your heating strategy, or radiators? No. I guess.
No, it's just a few radiators. Yeah, I mean, we tend to find that radiators are kind of the cheapest thing to put in. It's such a low heat load; they're going to be on so little. Just some of those dotted around the building felt like the most sort of pragmatic approach. And there is this thing with underfloor heating sometimes where because the building doesn't need much heat, if you've got underfloor heating, by the time people sort of realize that it's quite warm, you're sort of trapped in the heat and it still keeps heating up. So I quite like the radiator approach.
And this is quite an interesting and sort of current one, really, is with COVID-19, have enhanced ventilation rates been allowed at St Sophia, and what are the implications to the Passive House design?
Yes, so we are actually allowing for, well, at the moment, the design is ongoing. The big thing with the design on the ventilation system at St Sophia's has been, are we going to have a centralized system, which is what you'd probably expect in most new build passive houses, where you have one unit and there's big ducts that go through the school and then it sort of branches off? Or are we going to have decentralized, where we have a little unit outside inside each classroom going to the outside? And we tried in our Revit model to squeeze in the centralized system, but it just wasn't possible. We have only 2.5 meter head height in the main central corridor where we're going to have to run the ducts. So we'll be looking at doing a decentralized system, so individual units effectively for each classroom, possibly 2 classrooms sharing, depending on how that works with the capacity. But in answer to the question, we are looking at making sure that it's possible to up the ventilation rate to meet the higher sort of COVID levels of air exchange. So they could be run at that, or they could be run at the slightly lower level. In terms of certification, we'll certify it for the standard ventilation for healthy air quality, but we'll know that we can up it, and we can just very quickly, with the change of like one figure, change that in the PHPP file and inform the clients of the change to the energy demand for the school. But it's relatively minor in the grand scheme of things. Actually, we have looked at that already.
What have been the main challenges with this scheme? That's a very general question there. So what have been your biggest challenges, I suppose?
I probably have a different one from Alex and Magnus. From an architectural point of view, the biggest challenge for us is dealing with all the cavities. Cavities are just a bit of a nightmare. We used to always say that solid wall properties were like hard to treat. I feel like we should have always said the cavity wall properties are hard to treat, because we have to deal with air and moisture movement in a cavity that we just don't want to be there. So this building has an inner leaf and an outer leaf of brickwork with a cavity. It also has a beam and block floors, and it's a mixture of beam and block floors and timber floors, both of which are suspended with a crawl space underneath. So it's trying to deal with those spaces and make sure that we've got the moisture balance correct and the air tightness, that we can get the air tightness. We pressure tested the building and we smoke filled the solum underneath the building, and it just was pouring up the smoke into the building. We filled the building in like, I don't know, 15 seconds or something with smoke from underneath the solum. So that's, yeah, the existing construction of the building for me has been probably the biggest
challenge.
Yeah. But I'll let Alex and Magnus come with their own.
Yeah, I mean, I would probably say that the biggest challenge at the moment, anyway, is this fact that we're targeting another 10% saving on this, and this is where the contractor's involved. So it will be good if we can achieve that 10% extra over and above. However, the rest of it has actually been, I'd have to say, it's been very positive. Everybody involved in the project is all very much looking forward to see the result at the end of this. And I think it's a very positive feeling throughout the whole design team and parents' consultations and the likes. They're all very, very keen to see what this is actually going to achieve, because we've all heard about the quality of air and the comfort that Passive House can actually bring. So it will be very interesting, especially in an existing building.
Yeah, I would just add to that, Alec, another challenge for us as a client was the fact that this is the first EnerPHit we've done. So it's very much a sort of learning process for us. And it's great to be guided by Sarah through this process. But I would agree with you, it was an easy sell to sort of our elected members and to the community that, in fact, there's been a great sort of enthusiasm for it. So, you know, just given all the sort of climate change issues and whatever we're having. So, yeah, it was quite an easy sell in that respect.
So there's no problems, basically. It's fine.
It's all wonderful.
Yeah, it's all great. No, I mean, I think that's the thing, isn't it? It's so exciting to actually do something that you kind of feel is really going to make a difference. And sometimes with retrofits, I guess you just, you can do a lick of paint and it looks very nice, but with EnerPHit, you're just going that extra mile that you really know you're going to get something good out of it.
Yeah, I mean, I think people have to understand.
We got. No, you carry on, Alex.
Okay, I was just going to say, I think people have to understand, and it will be difficult because Sarah had to go very quickly through some of the layouts, but if you look at the layouts, so before and after, it's really quite a difference. I mean, when we say a deep retrofit, this is changing the school quite dramatically. And as Magnus said before, you will end up with what looks and feels like a brand new school, but in the location and a cost that's very acceptable. So it's a good process, and we're looking at potentially for doing the rest of our estate. All councils in Scotland are going to have this issue, whereby they've got to achieve the whole of Britain, of course, they're going to have to achieve this 2045 target of net zero. So it will be interesting.
Well, we've got we're at 4:10 now, so I appreciate some people may need to leave soon. There are a couple more more techie questions. If I don't know if you answer these ones off the cuff, but there's a couple there on heat pumps, cost and life of heat pumps. But these are getting into quite a lot of detail, aren't they? How are you treating the external walls?
Yeah.
Just do that one.
So the external walls are currently apparently they're insulated, but we have had a look inside and it's not great. So there's currently what looks like mineral wool that's been pumped into the cavity. So that what is there will have to be extracted because the current solution it's not robust in any way. And then the plan is to refill that with just like an eco bead, so like the EPS beads that they put into cavities. And then externally, we're going to be putting a porridge coat on the building, which is the airtight layer. So that's a pretty consistent approach around the whole envelope of the school. And then we're going to be putting mineral wool insulation onto that. We did look at potentially using like an EPS, but mineral wool was the kind of client's preference from a fire safety point of view, and also for the insurer for the building. So that's the current approach, and it's a pretty it seems like it's going to be quite robust. The main issue is trying to make sure that we're closing the cavity, because our airtightness layer is on the outside of the building.
Yeah,
which is the trickiest bit. So we're using a system which we've seen in some other EnerPHit projects, and we've spoken with the other architects, and it seems to have worked quite well, where we're just going to inject a course of a foam, like an airtight foam effectively, just at the bottom of the cavity to make sure it's fully closed. So you sort of drill in at 150 centers and you pump in this airtight foam. So that's the plan to close the cavity. But again, there's a real discussion that's ongoing with the contractor about how early we could potentially get that envelope set so that we could get the first pressure test. So it's constantly kind of trying to certainly work with the contractor to come up with a solution which is going to work and give us and the contractor some assurity quite early on in the project as well.
And this is where on Enefit you have these issues, isn't it? That everything needs to, it's much harder to make things join up, and you wouldn't necessarily use the approach, or you almost certainly wouldn't use the same approach on a new build.
No,
so there's always a little bit of figuring it out, isn't there?
Yes, absolutely.
Yeah. There's a question about the internal layouts, whether the internal layout changes are sort of normal for an end project, or is it project by project? Yeah, so I guess whether you think, yeah, I mean,
yeah, there's nothing really. I mean, we need to have a kind of decent sized plant room, but it's not because you have a lot of kit in an Enefit project, especially when we have a decentralized MVHR system, so we don't even have that to put in. So it's more just to do with, you know, the heat pumps and the electrical panels and all the stuff you have in a modern school. It's not, there's no certainly the plant requirement is less for an Enefit or a Passive House project than it would be for a standard build. So in that sense, you know, we're taking away a huge big old like a tower that sits on top of the school that was to do with services. We're taking away the big plant basement that's there. So in that sense, you get to rationalize and take away a lot of the services requirements. But apart from that, the rest of the school, the changes are not driven by Enefit so much as by the usability of the school.
How much did you have to change it, did you feel, due to getting that form factor a bit better, so getting the efficiency of the shape? Did that affect the internal, or was that more, because that was quite an interesting slide you showed there.
So you can see, you know, things like that's the tower. That's the grey one's existing. Can you see my mouse?
Yes.
Yep.
Oh, cool. So that's the tower that we're getting rid of. So we'd want to do that for Enefit because it's kind of a ridiculous thing sticking out the top, but also it's not required anymore because we don't need the services. What you can't see is there's a basement underneath the building here, which was for servicing as well. So that's coming out. So those were two bits that we were able to just take out to improve the form factor initially. So it started at 3.8, which is pretty high. I mean, we would like to have been down below 3 at the end, but it wasn't quite possible with the shape of the building. But you can see it's relatively small. And we did a little infill here. We did a little bit on the roof here. We actually ended up, this is actually the final design, it should be over here. So we took out the section that was there because it was actually, it dropped down below and had its own levels that came out. And this 2-story element just made a lot more sense from like a building usability point of view, and it improved the form factor. So that was kind of, yeah. That was it. I mean, I think if you weren't doing
the thing, isn't it? That
you might have still done the 2-story element and the sort of fill in here because that just made sense to make the school work. Yes. You might not have done that little infill there or that little infill there, but they're relatively minor. It was really taking away the surplus services that we just didn't need anymore because we were reducing the energy demand so much for the school it could be rationalized.
And I think that's something that maybe is a bit counterintuitive, isn't it? That you sort of think of Passive House as introducing plant MVHR system, but actually in a lot of cases we find that you're taking, certainly most of the heating equipment you're taking out, and even if it's a mechanically ventilated space, often you end up with a less kit as well if you use the Passive House approach, don't you? So yeah, that's quite an interesting one to bear in mind. Alex has got something to say on that too.
It was really just to sort of say that the model there, although it's very descriptive of the heat and the form factor, what it's not showing is the gradient. And the school was built on quite a gradient, quite a slope, and that enabled the architects previously to put in 5 separate levels. So as Sarah had mentioned there, actually what's worked out quite well, you've married the changes that were required to enable the access as well as reducing the heat loss. So it's a blended model, so to speak, and it has actually worked very well together, because we would have had to make these changes anyway if we were going to make it more accessible.
Yeah.
I think we're going to have to wrap it up now, unfortunately. Everyone's going to think of loads of questions now, as is always the way, but unfortunately we've gone to time. In fact, we're a little bit over, so we're going to wrap up now, and I'll just share my last few slides and say thank you so much to our presenters today and our panel, and Alistair, who unfortunately had to leave early, and also thank you to everyone who's attended today. Lots of great questions. I'm sorry we haven't got to all of them. So don't forget that this is part of a series of talks, so there are more. There's ways on your screen now. You should see some other ways that you can kind of engage and learn more about schools and education in Passive House. And then this is a list of the next ones coming up. So all of these sort of tie into each other, and yeah, really useful sets of webinars that are coming on. Yep, thanks again, everybody. Thank you to our sponsors. Once more, if I've lost the list of who it is, but thank you to the sponsors again, and keep in touch, and we hope to see you at the next webinar on the 26th, I think it was.